Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of electronic circuit. In this series, we are discussing the various components which are used in the electronic circuit. So, in the last lecture, we have discussed the electric cell. So, we just defined the many type of electric cell in which we have defined the galvanic cell and electrolytic cell. Now today we will discuss the primary cell, secondary cell, solar cell, moreover fuel cell. These are also the part of the electrical cell. So electric cell are used just to convert the chemical energy into the electrical energy. So one of the type of electric cell is the primary cell. This is also called the non-rechargeable cell. Basically, primary cell is a type of electrochemical cell that is designed to be used once and disposed of, or it may be discarded. So, primary cell is a one-time use cell, that is a non-rechargeable cell. And you also have seen in your remotes that this cell is the primary cell, and that is also referred to as the dry cell. So it is after its uses it can be discarded. So they lack fluid inside and are hence referred to as a dry cell. So they have a mechanism of an irreversible chemical reaction, and due to their high charge density as well as they discharge slowly. So they are the one time use cell, and these cells are having the mechanism of an irreversible chemical reaction, and due to their high charge density as well as they discharge slowly. So primary cell is not the rechargeable and cannot be restored to its original charge once it has been depleted. Once it has been depleted means when it is used, then it cannot have a charge. So it is a one time uses. So original charge cannot be retained in the primary cell as it is used. So primary cell are used in a wide range of application, including portable electronic devices, flashlights and the other devices that require a portable power source. This is a portable power source. Portable means we can take it from one place to the another. We can use in the many devices. So some example of the primary cell include the alkaline cell, zinc carbon cell and the lithium primary cell. So the electric cell which cannot be recharged electrically are called the primary cell. The original state of the electric cell cannot be brought back by passing the electric energy through the cell from any external source after cell is discharged. It means once a cell is discharged, it cannot be charged, it cannot be used further. So by passing the electric energy, if we try to pass the electric energy through it and we can use it as a rechargeable cell, but it cannot be recharged. So it is used one time and it is then be not usable. So these are the electric cell that cannot be recharged electrically. So this cell can only be replenished by the removal of an active material, means by putting the pellets of the ammonia into the electrolyte, means we have to change the internal material of this cell, then only we can make another cell by using this. So you can see the structure of the primary cell. You are having in this picture we are having the positive and negative. One terminal is the positive terminal and another terminal is the negative terminal. Moreover, we are having a zinc can that is just that all the material that is electrolyte and electrodes are in the cover of this zinc can. Now there are the other part also like carbon fluid, then there is a electrolytic plate here. So this is a one type of, there is a cathode mix and you can have the zinc can, and moreover there are the various part of this primary cell. Advantages of this cell, these are the very cheap and requires a little maintenance, and they are easy to use also. Another disadvantages of this cell, cannot be recharged electrically. Now if we want to use it, then we cannot recharge it again and again. Incapable of supplying the heavy current. Moreover, these cells are needed for a given output. The cell cannot be used continuously due to the effect of polarization. Means time to time it is used, but continuously we cannot use this cell. So, high, as it has a high internal resistance due to resistance of the plates and the electrolyte. What is the uses of this? We use this in flashlights, in the wall clocks, in the radios, in the clocks, in the remote control toys, games, etc. We use the primary cell. This cell is our daily use cell. Now example of this primary cell, like we have the voltaic cell, Daniell cell, Lagrange cell, manganese alkaline cell, mercury button cell. So there are various type of the primary cell. Now next is the secondary cell. What is this cell? This cell is also known as a rechargeable cell. Primary not rechargeable, secondary is the rechargeable cell and is a type of electric cell that can be recharged and used multiple times. As we can recharge it and we can use it for a multiple time. A best example that we are having the batteries in or the cell in our mobiles that can be recharged again and again and we can use it. So secondary cell consists of wet molten ions and they undergo reversible chemical reaction mechanism, and then we can use it, unlike the primary cell which is used once and then disposed of. So a secondary cell can be recharged by running an electric current through it in the opposite direction of the current that is used to discharge it. Means that current will discharge it, but the electric current will pass into the cell through the opposite direction, so it can be recharged again. So common example of the secondary cell includes the lead acid batteries, nickel cadmium batteries and lithium batteries. These type of cells are used in wide range of application that include powering portable electronic devices, vehicle and backup power system. Moreover, the electric cell in which the chemical process is reversible are called the secondary cell. Here the chemical process is reversible here, that we are charging this cell. So this is the secondary cell. So the original chemical state of the cell cannot be brought back by passing the electrical energy through the cell from any external source. These are electric cell and may be recharged electrically. Electrically we can recharge it, means we prepare a secondary cell, then we use it, then we recharge it through electrically, means by passing the current in it we can recharge these cells. Moreover, chemical energy is converted into the electrical energy when the cell is discharges, and electrical energy is converted into chemical energy when the cell is being charged. It is very interesting in this secondary cell that the chemical energy is converted into electrical energy when the cell is discharged, as we are just using the chemical energy into the electrical energy and cell will discharge. But when the electrical energy is converted into the chemical energy, then the cell will be charged. Now you can see on the screen that this is the type of cell. This is the secondary cell and you can see the opposite direction. Here the discharge and charging both are in the opposite direction. You can see here is a one anode, second is the cathode and there is a plate, and you are seeing that the current is flowing, and now the current will oppose in the opposite direction as is the discharging takes place. So you can see easily the discharging and charging is in the opposite direction. This is the the schematic diagram of the secondary cell. Here we are having the anode and the cathode, that the charge will be transferred from the one plate to the another plate, and A is the ammeter through which we can measure the current. Now, what are the advantages of the secondary cell? It is rechargeable, that is the main advantage of this cell, and it is capable of supplying the heavy current, and that will be used in many places. Moreover, they are having the high voltage per cell, moreover the lower internal resistance, longer lasting, because we can reuse it again and again. Now, what are the disadvantages of this cell? They are very expensive, they are having a lax mechanism strength, self discharge, and moreover the plates shed easily, require the careful maintenance. Moreover, there is also a requirement of the placement of the electrode whenever it is destroyed. So, there are some disadvantages of the secondary cell. Now, if we talk about the uses of this secondary cell, it is used in extreme of high temperature and in conditions where vibrations is experienced here. So, standby supply, and it is used in the motor vehicles also. Now, there are some example of the secondary cell which we use is the where we use as are the lead acid accumulator, alkaline cell, etc. So, there are the various cell which are used in the various appliances. So, the lead cell, lead acid accumulator and the alkali cell are used as a secondary cell. So, these cells are used in the extreme of the high temperature and in the condition where the vibrations is experienced. Means in the worst condition we can use this secondary cell, and they are used in many places. So, that. Now, what are the reversible cell? Now, another type is the reversible cell, that are the third type of the battery. Now, this reversible cell is a name given to the third type of the battery, and the reverse cell differs from the primary and secondary cell in that a vital component of the cell is kept apart from the rest of the cell until the before activation. Now, the component which is mostly isolated is the electrolyte. So, the electrolyte remains inactive in the solid state unit. The melting point of the electrolyte is achieved. So, we keep the electrolyte away, allowing for the ionic conduction and therefore activating the battery. So, self discharge is successfully eliminated and the chemical deterioration is minimized. So, that is in the reverse cells or the reverse batteries. So, the majority of the reverse batteries are only used once before being discharged. So, self discharge is eliminated as well as the chemical deterioration is minimized in the reversible cell. In the missiles, torpedoes and the other weapons use the reverse batteries, and they are utilized in the timing, temperature and the pressure sensitive mechanism also. So, whenever we require the pressure sensitive, we require the temperature sensitive, then we use this reversible cell. And these are also known as the deferred action batteries, because reverse batteries are special purpose primary batteries normally designed for emergency uses. So, the electrolyte is stored separately from the electrode which remains in the dry inactive state. So, the battery is only activated when it is actually needed by introducing the electrolyte into the active cell area. So, this has the double benefit of avoiding the deterioration of the active material during the storage, and at the same time it eliminates the loss of the capacity due to the self discharge until the battery is needed. They can be stored for the 10 years or more than that and provide the full power in an instant when it is required. So, these cells are used for a longer time also. So, they are the various cells. So, you can see on the screen that this is the reversible cell. You are seeing very clearly that this is the gas generator here, and here we are having the cell cavities and electrolyte manifold, and there is a power in the power to the system is supplied to the cell cavities, and moreover activation signal is sent to the batteries gas generator so that it can generate the system. Now there is a piston that is used to send the, and you can see on the upper part there is a electrolyte full tube. That electrolyte is filled inside it. So this is the, now finally we are having the most reverse cells are used once and then discarded, and they are used in timing, temperature, pressure sensitive, and moreover we can use in the missiles, torpedoes and the other weapon system as well as in the solar system. So another type of the cell is the fuel cell. What is this fuel cell? Just to give the brief idea about the fuel cell. In the next lecture we will discuss about all regarding the fuel cell, type of fuel cell and how it works, and nowadays how we are using the hydrogen type fuel cell and how we use the water just to convert into the electric. So first we just understand what is the fuel cell. Basically fuel cell is a type of the cell that falls under the fourth category of the electric cell. That fuel cell are comparable to the batteries with the exception that all active components are not included in the devices as we are having in the batteries. So these are comparable to the batteries, and with the exception that all active components are not included in the device. Active materials are injected into the batteries from the outside source in the fuel cell. The fuel cell varies from the battery in that it can produce the electrical energy as long as active material are delivered to the electrode, but it will shut down if these material are not available. It is very clear from here that the active material is injected inside the cell and it works whenever, as long as the active materials are delivered to the electrode, it will work, as well as if it is removed then it will be shut down. So this cell works on the availability of the materials. The use of cryogenic fuels in the space vehicles is a well known use of a fuel cell. Although recent development had resignated interest in the range of system with applications such as utility power, load leveling, on-site generators, electric cars that use a fuel cell technology for the application that has been slow to develop. Means nowadays the research area of this fuel cell is how we make this fuel cell so effective and usable. We can use it for the further application. So these were originally developed for the space vehicles. However, recent development has led to them being used in a variety of systems like electric vehicles, utility power and on-site generator. So nowadays fuel cell can are vastly used in the development of the electric vehicles. Fuel cell can deliver the zero pollution and high efficiency just to avoid the air pollution and global warming dilemmas. So a fuel cell is an electrochemical power generator device that combines the hydrogen fuel with the oxygen for the air to produce the electricity. This combines the hydrogen fuel with the oxygen from the air and just is produce the electricity with the water and the heat as the only byproduct. So, you can see on the screen that this is a simple reaction and that produces the emission free power. You can see hydrogen plus oxygen and it is producing the electricity, power, water vapors. Means we are producing the electricity through the water. Hydrogen and oxygen will produce the electricity. That is the work of the fuel cell. Unlike traditional power generators, fuel cells are more fuel efficient and it operates with the little noise, produce no harmful emission, so it is a environment friendly and no hazardous can be produced by using this fuel cell. Fuel cells and the batteries are similar as they both generate the electricity. However, a battery stores the energy while a fuel cell uses an external fuel such as hydrogen, allowing it to continue operating as long as the fuel is available. Means battery can store the energy, but the cell is used as the material is supplying to the fuel cell and it is then used continuously. It can be in situ use, but here the battery can store the energy. So, unlike the conventional batteries, however, fuel cell do not contain the harmful material and all are biodegradable and the other materials are used in the fuel cell and are very little maintenance since there are no moving part in the fuel cell. So, these fuel cells are used just to produce the electricity without damaging, without pollution, without creating the pollution, without damaging anything. These fuel cells are used. Moreover, they are not so much expensive as compared to the other batteries. So, a fuel cell is an electrochemical cell that reacts hydrogen fuel with the oxygen or another oxidizing agent to convert the chemical energy to the electricity. And fuel cell are different from the batteries, require the continuous source of the fuel and the hydrogen and the oxygen. Usually oxygen we can take from the air and it to sustain the chemical reaction, whereas in the battery the chemical energy comes from the chemicals already present in the batteries lecture. You can see there the fuel batteries in the battery lecture where we are having the description of that. So, fuel cell means we do not require any chemicals, but here the hydrogen and the air will be, hydrogen and the oxygen will combine and that produce the electricity. So, fuel can produce the electricity continuously as long as the fuel and the oxygen are supplied to the system. So, they are used for the primary and the backup power for the commercial, industrial and residential building, and in the remote or inaccessible area we can use these fuel cells, and they are also used to power fuel cells vehicles including forklifts, moreover automobiles, buses, boats, motorcycle and the submarines. We can use in this cells in the many application. Fuel cell are classified by the type of electrolyte we are using, and they use what type of electrolyte on the basis of that can be defined, or they can be classified by the difference in the startup time, which is range from 1 second for the proton exchange membrane fuel cell, that we will discuss in the types of fuel cell, that how these cells are work. But the fuel cell are classified on the basis of the time, startup time, in which PEM, that is a proton exchange membrane fuel cell, that takes a 1 second, moreover to the 10 minutes, that is the solid oxide fuel cell. These are the various part of the, or we can say they are the various category of the cell, that depends upon the time period. So, What fuel cell consists of? Again, the similarly as we are having in the electric cell, it is having anode. So, an anode, a catalyst, causes a fuel to undergo oxidation reaction that generates the proton, that is a positively charged hydrogen ion, and the electrons. So, these protons flow from the anode to the cathode through the electrolyte after the reaction. So, at the same time, the electrons are drawn from the anode to the cathode through a external circuit and producing the direct current electricity. Another is the cathode. At the cathode, another catalyst causes hydrogen ions, electrons and the oxygen to react, forming water. Third is the electrolyte, which allows positively charged hydrogen ions, protons to move between the two sides of the fuel cell. So, you see diagram that it is very clear. Here we are having the two plates, excess fuel, right hand side we have the unused gas outlet, fuel in, air in, left hand side there is a fuel in and right hand side there is a air in. In between that we are having a electric current. Now, you see hydrogen atom how they are changing from one position to the another position. At the bottom you can see we are having the anode and we are having the cathode. Now, it is moving from anode to the cathode. Hydrogen atom are passing from anode to the cathode, and there we are having a oxygen that will be combined there. Then electrolyte that will transfer the hydrogen from anode to the cathode, and then we can get it. So, this is the hydrogen atom. So, this fuel cell are used in many purposes, and this is the working condition. In the next lecture, we will discuss regarding the fuel cell, type of fuel cell, how it works and what are its uses. So, thank you very much.